I'm Dr. Nehemiah Mabry. I'm a civil structural engineer. Today I'll be answering your questions from Twitter. This is City Support. All right, at JB Rice JB asks, how do you safely demolish a 28-story building? So the goal when you're demolishing the building is to get it to implode or basically collapse directly on its own footprint. The structural drawings are studied, load-bearing supports are identified, and detonators are placed there so that they can sequentially or at a certain time all be executed, and then the remaining portion of the building has nowhere to fall but directly down. And then the weight of the building itself then causes it to continue to collapse upon itself. At Aaron of Boston asks, how are underwater tunnels made, i.e. Sumner Tunnel? First, you have to make sure that you can get down under the water to begin the work. What we do is place makeshift dams down into the water to seal out certain parts of the water, and then the water inside of that dam is literally pumped out. So now you have a section of the water that workers and machinery can get down, and we have what we call a tunnel boring machine that can then tunnel through in the direction that we want the tunnel and also keep the pressure or the water out. And that being done allows there to be some sort of prefabricated tunnel. And by prefabricated, I mean it was created outside of the water to then be placed into the boring hole. Sometimes this is done on both sides of the tunnel at the same time. And then when it is done, the makeshift dam is removed, the water then continues, and the tunnel at that point is connected to the road that leads to it. At Archie_tradition asks, what city has the best urban design? Amsterdam in the Netherlands is known for its canals, which create a pretty nice grid. I would say in general, Singapore has been recognized as a country that has pretty good urban design. Newer cities have the advantage of looking at how cities were designed in the past and identifying areas that were perhaps not as optimal. You want to make sure that there's a significant amount of housing and that there's more room to develop as necessary. You want to make sure that there is affordable housing. And then you want to make sure that there's efficient routes from where there are primary residential neighborhoods to the areas where people do a lot of their working, such that you don't have to have everyone driving individually, creating more carbon emissions. You want to see green spaces, essentially harmony between the ways that people live, they work, and they play. At Meow Janae asks, isn't it crazy how someone designed roads and highways to get places? Like, how do they know where to go? In some respects, we have our indigenous ancestors to thank, particularly here in America. Oftentimes, these roads were footpaths. People were traveling from one place to another, and they were just basically trying to go in the optimum directions to get from one place to another natural resource. Roads over time kind of naturally took the place of what were just heavily trodden paths. At Signey Ray 497 asks, honestly, how the heck did engineers reverse the flow of the Chicago River in 1900? Naturally, the Chicago River had a flow north into Lake Michigan. As the city began to grow, a lot of pollution from the city would go into Lake Michigan, and they ran into a problem of actually consuming their own pollution when they got their water from Lake Michigan. What they basically did was locate a high point not too far west of Chicago, and they dug a canal that redirected the water, and because it was on the other side of the high point, the gravity naturally caused it to flow downstream as opposed to upstream. And so they basically just rerouted a section of it. At engineers_feed asks, what is the most mind-blowing engineering marvel you know about? One of my favorite bridges is the Malau Viaduct. It's actually the tallest bridge in the world. It's about 1.5 miles long, and the height of the towers are actually taller than the Eiffel Tower. It's a cable-stayed bridge, one of my favorites. Cable-stayed bridges transfer the loads or the strength that the cables experience to support the deck of the bridge, and they transfer it back to each individual tower. It really looks sleek because it has to be symmetrical, and the fact that it's a tall bridge means that you can get nice clouds and fog that makes for some pretty stunning photography. At Mouse_B, question for New York City. If you had to do it all over again, would you build elevated trains instead of subways? There are basically pros and cons for building underground versus above ground, where if you're above ground, you have the convenience of being able to work on it quite easily. One of the disadvantages is that you're more exposed to the weather. An advantage of having subways underground is they don't have to worry about the constant snow load or the winds that, say, a road would have to deal with. At this point, I think it's probably better underground. You really don't want the additional congestion of having to repair around all of the people that are already in New York City. At Nico Entombed asks, how the frick are skyscrapers even made? This is a pretty basic skyscraper design. It gets narrower as you get up higher. But a lot of times these structures are designed by either reinforced concrete or very, very large steel I-beams. This is a very small cutout model of one where you have a web, a narrow web, and then you have a wide flange at the top or bottom. I-beams can form horizontal supports, or very thick ones can be used as columns for a skyscraper. And the more you want your particular I-beam to carry, the thicker you will make these different components. At Oberly_ asks, to be honest, if you aren't using number 9 steel rebar bars and concrete beams, what kind of civil engineer are you? So what she is referring to is the steel bars that we use inside of concrete to basically reinforce the strength. Steel is very strong in what we like to call tensile strength. It can resist being pulled. Whereas concrete, not so much strong in that type of force, it's much stronger in compressive strength, being pressed on. So in certain parts of our concrete, we would place steel bars of different sizes to be able to reinforce the strength in that area of the structure. And the number of the rebar represents the diameter of that particular steel bar. Now, number 9s, it represents 1 square inch of cross-section, so it makes the math a lot easier to calculate. Every time we add 1 number 9 rebar, we've just added 1 square inch of steel reinforcement for that area. At Leah Leeson, how are rope bridges built? So the first step is just to see how can you get that first rope from one side to the other. It probably was either walked over or hiked over at first, or perhaps thrown or shot over using an arrow in some of the earlier cases. And once that first rope reaches the other side, now you have a system to get other things across using a system of pulleys and levers. These rope bridges are very basic cases of suspension bridges. At Bond_Bond 222, how do bridges not collapse? Well, we design bridges to be able to last for 50 to 70 years on average. So in the case of a suspension bridge, what you have is a long wire cable connecting from one support to the other. They have vertical cables that are going down from that cable that are in tension or being pulled down by the weight of that particular bridge deck. When this is happening, that is actually transferring the load back to the top cable, and then the top cable is responsible for transferring that load back to the tower. That support distributes the load across these columns and transfer it back to its foundation. We run a lot of tests on the type of material to make sure that it can withstand all of the temperature cycles, all the wet, the dry cycles, the fatigue from the constant use of traffic. We do this to a point that we have a high reliability or a high level of confidence. It's not gonna collapse for a significant amount of time. At Enberry asks, the civil engineers in this city really have zero clue on traffic flow. How can 90% of lights be red as you get to them? Traffic studies are based on data. They look at the number of cars that are actually passing through a particular intersection or heading in one direction at different times of the day. They measure this sometimes by using sensors in the ground, sometimes they're cameras, or they can be old-fashioned and actually have a person go out there and literally count the cars. Whenever this changes, they're able to optimize the phases or the changing of the lights at different times of the day. They want to prioritize where there is a heavier flow of traffic. Roads that have a high volume of traffic, there's a higher speed, they're given more time for their red and even yellow lights because they don't want to jam up traffic in that direction. So that being said, perhaps you're on a road that doesn't have high priority, or there needs to be a refresh in the traffic studies of that area. At Toronto Cayo, did the London Bridge actually fall down? Yes, multiple times. There was a bridge around the 11th century that was reportedly torn down by a Viking invasion. However, after that was rebuilt, the nursery rhyme you're referring to could likely be speaking of the fact that during the longest tenured bridge of about 622 years, the London Bridge actually went through a lot of fire. It experienced a lot of wind or tornadoes. It experienced a lot of rain. And so over time, it became a joke that not only the London Bridge falling down, but one poem written about the same time states, the London Bridge is broken down, speaking to the constant need of repair that it was in. Next question, what do you think? How will our future cities look like? A, B, or city. Any highly advanced city is going to need to make sure that there is an integration of green spaces, not only for our oxygen, but just for our enjoyment and well-being. The more that we get rid of our natural green spaces, the less we're able to have that oxygen naturally generated in our environment. I see that they're all high vertical structures. And that really speaks to the fact that we're going to need to get more and more comfortable with building up, because building out isn't going to always be an option. At ASCE tweets, how will Florida cities work? What can civil engineers do now to help us get there? First of all, American Society of Civil Engineers, I would think that you would know the answer already. Shout out to y'all. You could look at things such as artificial islands or oil rigs or even cruise ships to get an idea of how these things could be worked. Oftentimes, they are built with anchors connected to the ocean bed or the sea floor to make sure it doesn't float away. Other times, they can have very long columns of significant weights distributed underneath the platform so that it's able to be steady, and then weight can be built or structures can then be built on top of it. At Babylon on the replay asks, I know it doesn't rain frequently in California, but why the frick does the drainage suck so bad in so many areas? Like, did the city engineers not consider rain at all? I'm pretty sure they consider rain, but they consider a certain amount of rainfall. And that was based on the historical data at the time that they designed the city. As the environment begins to change and things begin to switch up, sometimes the amount of rainfall that was once expected to be very, very rare becomes more frequent. And so oftentimes you do have puddling that cause engineers to have to go back and redesign. We begin to now have new information that allows us to design more for the present than for the past. And so you could be experiencing something that just is in need of a revised design. At Catherine Gold asks, question for engineer types. If you walk under a bridge and you see crumbling concrete and exposed rebar, is that bad? Asking for the city of Cleveland. Well, it's not necessarily bad, to be honest. The concrete that is at the bottom is actually used as cover to cover the steel rebar. We've only designed it so that the steel is actually resisting most of the strength. The problem, however, is that that steel is now exposed. And so as the steel begins to corrode and rust, then it actually does get bad. And so if you see exposed steel, in some cases, it just needs to be cleaned and recovered. In other cases, it could be pretty bad. At Chrissy, how are sinkholes created? My sister. You cut a hole in the counter and put a sink in it. Sinkholes are basically just areas of non-compacted soil. Sometimes there was water there that has been drained out. And so now you have this big old gap underneath the surface that whenever it experiences enough weight at the top, it could sink. At Lit Industrial asks, how would you design a new city in the desert with an unlimited budget? This brings to mind a city that's already been proposed in Saudi Arabia, known as The Line, as its nickname, Neon. Pretty much very narrow city that stretches several miles. There will literally be 2 walls that are able to support several overhangs, or cantilevers as we call it, that can support green spaces, residential housing, transportation. When you're just looking at a short footprint and you're building up as opposed to out. You can increase the optimum travel from one end to the other by making public transportation just a straight line. Being in the desert, when you're thinking structurally, sand is actually pretty strong. It has a high bearing capacity. That being said, you have to bring in additional cement and other materials to make sure that this sand can consolidate and not be as shifty as we know sand to be. I think it's pretty challenging, but I'm not one to rule out what human ingenuity can do. At Alexis_Brittany asks, what does building a bridge even have to do with math? How we design a bridge, we have to start by saying, whenever a force is applied over an area, we divide the area that's going to experience that force by the value of that force to get what we call the stress. So there's math right there. We measure the strength of the concrete in terms of pounds per square inch. How many pounds per square inch of area can this take perpendicularly? We call it compression strength. The cylinders are taken into the lab and put into a very high strength compression testing device until it breaks, until it fails. And then we can say to ourselves, this concrete has a failure strength of 5,000 pounds per square inch. We then come back to our structure, our bridge, and we determine if that concrete is strong enough to hold up the weight that we're expecting this bridge to experience. In other words, it's a lot of math. At Ross Mingna asks, how is everybody fine with the fact that skyscrapers sway back and forth in the wind? Skyscrapers have to worry mostly about wind. So as wind is hitting one side of the building, it's going to naturally want to sway a little bit. If wind is able to rush by it extremely fast and it's feeling a lot of positive pressure on this side, it creates what we call a negative vortex, which can cause it to vibrate pretty heavily. Throughout a very tall building or skyscraper are installed dampers, which basically counteract the swaying of the building. A certain floor may have a very large weight, such that as the building begins to sway, say, this direction, the damper would then move in the opposite direction to kind of counteract the amount that is being swayed. But they are hidden from your typical user of the building. They have hydraulic actuators that push from one side to the other, usually matching the frequency that the building is naturally swaying in the wind. At Cade T. Kelly _ asks, concrete versus cement. What's the difference? Well, cement is actually a powder that creates a paste when mixed with water, and concrete has not only that cement, but also rocks to make it one big recipe. So cement is actually an ingredient inside of concrete. At St. Clement asks, these monstrous elevated freeways, whoever thought those were a good idea? Well, the elevation of a freeway has to take into consideration the vertical space or the vertical clearance of whatever is traveling underneath it. Whenever you have multiple intersections and several freeways passing other freeways, you have to make sure that the minimal point is still high enough for whatever traffic is traveling underneath it. But you can't just step it up whenever you need to. And so oftentimes the vertical curve needs to be gradually created over time. The alternative would be to go under it. It wouldn't be as easy to maintain. And so this calls for certain areas to look unnecessarily higher than they need to be, but it's ultimately to try to accommodate a very smooth experience for those who are traveling on it. Those are all the questions I have time for today. I had a lot of fun. Thank you so much. I hope you enjoyed and learned something. Thanks for watching City Support.